Have you ever wondered how we can predict the invisible movement of water beneath our feet, especially when it is under pressure? Understanding this hidden world is crucial for managing our most vital resource. It all comes down to a fundamental relationship between water pressure and its height in the ground. Piezometric head and elevation are intrinsically linked as components of what we call hydraulic head, which governs groundwater flow. Piezometric head specifically represents the height to which water would rise in a well or piezometer that is screened at a particular depth within an aquifer. This measurement directly incorporates the pressure of the water at that point. Elevation, on the other hand, is simply the vertical height of that measurement point above a chosen reference level, such as sea level. The core reason these two concepts are so interconnected lies in the principles of fluid mechanics and energy conservation. The total energy of water at any given point in an aquifer is expressed as the hydraulic head. This head has three main components: elevation head, which accounts for the potential energy due to height; pressure head, which reflects the potential energy due to fluid pressure; and velocity head, which is usually negligible in slow-moving groundwater. Piezometric head itself is effectively the sum of the pressure head and the elevation head. By understanding this combination, we can determine the total energy available to drive water movement. To practically assess this relationship, hydrogeologists use piezometers, which are specialized wells designed to measure the water level at specific depths. When a piezometer is installed, the water level within it rises to a certain height. This observed water level, relative to a fixed datum like sea level, is the piezometric head. By measuring the piezometric head at multiple locations and depths, we can create a detailed picture of the potentiometric surface, which is an imaginary surface representing the total hydraulic head throughout an aquifer. This surface helps us map and visualize the direction of groundwater flow. A key insight in hydrogeology is that groundwater always flows from areas of higher hydraulic head to areas of lower hydraulic head. This might sound obvious, but it means that water can actually flow uphill if the pressure head component is significantly greater than the elevation head. For instance, in an artesian aquifer, the piezometric head can be above the ground surface due to confining layers trapping water under pressure, causing water to flow upward and even gush from wells. This phenomenon underscores why simply looking at elevation alone is insufficient for predicting groundwater movement. Ultimately, the relationship between piezometric head and elevation provides the essential framework for predicting how and where groundwater will move. By meticulously measuring and mapping these values, we gain the ability to understand complex subsurface hydrology, make informed decisions about water resource management, and even predict the spread of contaminants underground. It is this comprehensive understanding of hydraulic head that empowers us to effectively manage and protect our valuable groundwater systems.
If you love learning about water, like, subscribe, and keep exploring with us.